In this lecture, I will show you how to determine the electromotive force of a galvanic cell. Now, this electromotive force is the potential difference when you are not drawing any current from the cell. Now, if you try to have the potential difference using a voltmeter, you will be able to do that, but that will not give you correct result. I have shown you that the electrode potential depends on the concentration of the species taken in the cell. So if we draw current from the cell, the concentration will change, since in a galvanic cell what happens, the chemical energy is being converted to electrical energy. So there is consumption of the chemical energy, and at the cost of which we get electrical energy from the cell. So if we use a method which don't stop the reaction, it allows the reaction to continue, then the reaction species will experience a change in concentration. And since the potential depends on concentration, what will you find? You will find the potential difference to change continuously. So that is the way of measuring the potential difference by actually disturbing the system. However, the effect is not that much. So that if you apply voltmeter, you will get the potential difference, not very accurate, but you will get it almost nearer to the original value. It is a almost equal value. You will get the value which is almost equal to the original value. So it is not the case that you get a result which vary much with that of the original value. But if you want to be accurate in your experiment in determination of the potential difference, you have to use a different machine instead of voltmeter, which is the topic of this class, that is potentiometer. Now, the only motive to use potentiometer is not to get the exact result. We will get the exact result, but the main focus is that while measuring the EMF of a galvanic cell, we must not disturb the cell. So if someone gives you a galvanic cell and he or she asks you that tell me the potential difference that is acting between the two electrodes when the circuit is not closed, so that is he or she is demanding to get the electromotive force, then if you connect the voltmeter, you will get a result that is almost nearer to the original value, the accurate value. Not exact, but almost equal to the original value. But what you are doing is that if you allow the voltmeter to connect, you actually switching on the circuit. You are making the circuit close so that reaction starts, and it will suffer a change in concentration of the reacting species. So that is the limitation of measuring the potential difference of galvanic cell with voltmeter. Now, what potentiometer does? It does not allow the reaction to occur, so that without disturbing the cell, you can have the potential difference. When you are not drawing the current, that is reaction reacting species are not getting destroyed, so it has a maximum chemical energy, so it will give you the maximum potential difference. That maximum potential difference that is obtained experimentally is called the electromotive force. Now, what is a potentiometer? How it acts so that without disturbing the cell and without causing the change in concentration of the reacting species that are present in a cell, how we can determine the EMF, cell EMF using the potentiometer. So let us first learn how potentiometer works. So you have to draw the circuit. Now for this purpose, we are taking a wire. This wire must have two characteristics. One is it must have uniform cross section throughout. It must have uniform cross section throughout, so that we will use a trick and bypass the measurement of the EMF by actually measuring the length. Now we will convert, I will show you in the course of this lecture, that we will actually measure the length of this wire, and not in any way we have to determine the potential, but it will give us potential. So we will get the EMF of this cell by actually measuring the length. Now if we measure the length, now it must be guaranteed that the wire must have uniform cross section. And another thing is that it must have a high resistance. It must have a high resistance. Now there is no limitation, there is no restriction, not limitation, restriction in the length of the wire, that it should be 1 meter. It may be of comfortable size, what you need to have the experiment done. Now we are using a storage cell here. Storage cell is nothing but a battery, and you are connecting this storage cell to this wire AB. Now what about this wire? This wire has very little resistance and highly conducting, and this wire, this is the main part of our experiment. This wire has a uniform cross section and has a very high resistance, but these connecting wires have zero or little resistance, so that it does not affect the experiment. So we are connecting this wire with a storage cell, so that it will develop a potential at the two terminals of this wire, that is at A and B. So if we have a potential here X and here we have Y, then this potential X will be forwarded to this point and this potential Y will be forwarded to this point. This is the case. And from A to B, this potential X will gradually fall, will smoothly fall, since it has a uniform cross section, and it will fall gradually from X to Y. That is the purpose. So if this potential is, say, plus 0.5, so the potential here will be plus 0.5. And if here it is minus 0.5, it will be here minus 0.5, since the potential is not getting destroyed in this conducting wire. But here there will be a smooth drop in the potential from plus 0.5 volt to minus 0.5 volt. This is our purpose. So you see potential drops from A to B. Now at this point A, the cell with which you are concerned to have its EMF to be known, that is, it is your galvanic cell, and EMF of which you are eager to know. So you connect the cell, you connect the galvanic cell whose EMF is unknown and you want to know it. You connect the cell, but the connection must be in this pattern such that it opposes this storage cell. So for this, what you have to do? You must connect the point A to the positive terminals of the storage cell and the galvanic cell, both. Now at this part you take a galvanometer, so that will exhibit deflection if there is any potential difference between the two terminals of its connection, and the connection continues and it ends on a pointer that is mounted on this wire, and you can slide it over the length AB to and fro. So you have a connection here, additional circuit. This is the cell whose EMF you want to know, and you connect it in that way so that it opposes the potential of the storage cell. Now the other end is connected to this wire AB through a galvanometer. Now this end is free to move over this wire. So you have a jockey here, and the pointer is mounted in the form of jockey on this wire, so you can move it through this upon this wire. Now a point will come, say P, where you will see no deflection in this galvanometer. What does that indicate? You have slided this pointer throughout this path anywhere between A and B, and you have found a point P for that pointer where you are getting no deflection in the galvanometer. So that indicates no deflection means the drop in potential from A to this point P is exactly balanced by this EMF. You see there is a potential difference, and the potential drops from A to B for this storage cell, and at this point you are getting no deflection. So it implies that there is no potential difference at the two terminals at this particular position. So the drop in potential from A to P, is exactly balanced by the EMF of this cell. Only at this condition it will experience null potential, so there will be no deflection. So you get this point to represent, and this length AP to represent the EMF of this cell. I have just told you that we will bypass our determination method from determining the potential to actually measuring the length. So we got the length that is proportional to the EMF of this cell. So if this is our cell, say G, galvanic cell, then EMF of this galvanic cell will be proportional to length AP, this length AP. Now what is the proportionality constant? This is the potential gradient. Now you have the drop in potential, the value of the drop in potential, and you have the length here, say L. So the entire drop in potential, say VAB by L, that will give you drop in potential per unit length. So per unit length, what is the drop in potential? That is the potential gradient. Now for this technique, you thus need a uniform cross section. Since you are telling that the potential gradient is, the value of the potential gradient here is equal to the value of potential gradient here, everywhere within the wire, anywhere within the wire. So the cross section must have uniformity throughout the length AB. And also it must be of high resistance, since the potential drop from this terminal to this terminal is actually must actually occur between A and B. So it is this resistance which drop the potential. So this potential gradient into LAP will give you the EMF of the desired galvanic cell. So you get this. Now, do you know this value? If you have to know this value, you need to have the potential, you have to calculate the length, and you have to get it. Then by having the value of LAP, and if you multiply it, you will get the EMF. So that will be the solution. So in this method, you can determine the EMF of galvanic cell. So if someone tell you the potential gradient, you just multiply the potential gradient by the length. At length of this AP section, since at this point you get the null deflection. Now another way to determine this using this method is to take a reference. So that will simply remove this one. That is, no need to know, need to know, KNOW. No need to know the value of this potential gradient. So you may take any storage cell here, and without knowing the voltage, just if you follow the next steps, you can have the value of the EMF of the desired cell. So to have this, you need a reference. So you got this relation. Now you replace this one by a standard cell, say S, standard cell. Again, the connection must be in the way in which it opposes the storage cell, so that the point A must be connected to the similar terminals with similar charge of both storage cell and the standard cell. Again, you have to find the point where there is null deflection, that is no deflection. Let this point you get here. So again, you have to connect the other end to a pointer through a galvanometer, and you have to find the point for which there will be no deflection in the galvanometer, so that it will imply that the drop in potential from A to Q, is exactly balanced by the EMF of this cell. Then there will be no potential difference at the two terminals of this galvanometer, so there will be no deflection. So here we can write ES proportional to L AQ, obviously. So this EMF is getting balanced by the drop in potential from A to Q within this length, so it will be like this. Again, you are not changing the wire. See, you are not changing the wire, and you are not changing the storage cell. You are taking any storage cell, but you have to perform these two experiments with the same storage cell. That is for the galvanic cell whose EMF you want to know, and for the standard cell whose EMF is exactly known. This is acting as the reference. So this is ES equals to this VAB by L into L AQ. So you get the expression for the standard cell. Now just divide 1 by 2 so that it will give you EG by ES equals to, now see, this potential gradient will cancel out and you will get LAP by LAQ. So this is the relation. Now this is a standard cell whose EMF is accurately known. So you have the value of this standard cell, and LAP, here you got the point P for the galvanic cell whose EMF you want to know. So you just have a scale here. So just by observing the point, the position of the point, you can get the length. So you get the value of LAP, you have the value of ES, and again in a similar way just observe the position of point Q on this scale. So you will get the value of LAQ. What you will get? You will get the value of EJ. So this is how EMF of a galvanic cell can be determined experimentally. So this is a experimental procedure with the help of which you can have the EMF of a galvanic cell. I am repeating that you can also have the potential difference using a voltmeter, but when you connect voltmeter, the reaction starts, and if reaction starts, you are actually disturbing the cell. The person who is giving you the galvanic cell and asking you for its potential difference, you are giving the answer after disturbing his or her cell. So you must know another method by which you can measure the potential difference without disturbing the cell, that is without consuming any current from the cell. So that is the maximum potential difference, since potential difference is a function of the chemical species, and since you are not withdrawing any current, so the reactant species will be in maximum amount, so you will get the maximum potential difference using this method, and that is termed as the electromotive force. So electromotive force exists even when you are not drawing current from the cell, and it is the potential difference when the circuit is not closed. Now what about this standard cell? Standard cell means you must have its EMF accurately known, and it must not change its EMF. It must not change its EMF during this experiment. So a standard cell will be so you can call a cell to be standard cell when it has a high reproducibility. That is, it can exhibit constant EMF for a long time, and also another property it must have, that is, its temperature coefficient must be very, very low, so that it allows you to experiment in a wide range of temperature. So with change in temperature, its EMF does not change that much. So you got the idea about how to determine the EMF of a galvanic cell. Now I will talk about the standard cell. This is an example of a standard cell, which is the Weston cell, and it is the widely used one. You see, this is a H-shaped vessel having a connection. Now you have a amalgamated cadmium here, and here you have CdSO4 hydrated CdSO4 cadmium sulfate crystals, and here you get a saturated CdSO4 solution, and in this section you get a paste of mercury and Hg2SO4 mercurous sulfate, and we have mercury here. Now this vessel is sealed, and this platinum wires coming out of this vessel, it will act as the anode and the cathode. So this is the Weston cell. This one you have to connect after connection of galvanic cell. Now comparing the lengths obtained for the null deflection of this galvanic cell and this Weston cell, you will have to determine the EMF. So how this works, you see, if I represent this cell, it will look like a train having a lot of compartments. Here we have platinum, it will act as the anode, and then we have cadmium amalgam, then we have crystals CdSO4 dot 8/3 H2O, this is crystal. Then we have saturated CdSO4 solution, saturated CdSO4 solution, so the electrolyte is common. Then we have a paste here, so it is Hg2SO4, then we have mercury here, then we have platinum. Such a long cell we have. Now what will be the reaction? The anode reaction within this cell will be the oxidation part, that is Cd arrow Cd2 plus 2 electron. So Cd will lift the electron to this platinum electrode, and it will come here, Cd2 plus in the solution. And in the cathode part, what we will get, this electron will come externally, and here it will perform the reduction part, and it will be like Hg2SO4 plus 2 electron, it will give you 2 Hg, it is plus 1, it is minus 2, and you have the sulfate ion. So the cell reaction is, what is the cell reaction? Cell reaction is Cd plus Hg2SO4 arrow CdSO4 plus 2 Hg. Now this cell will exhibit a constant EMF for a long time, and it has a very small temperature coefficient, that is rate of change of electromotive force with temperature. It is very low amount, so that it allows you to perform the experiment in a wide range of temperature. Now in the next lecture, in lecture 6, I will talk about a very important topic, that is Nernst equation, and that will also allow you to determine the EMF of a galvanic cell, but that is theoretically. So in the next lecture, we will give a theoretical support to this electrochemical cell. We will put some light on how you get the electrical energy, what is the source of electrical energy, and also you will be able to determine the EMF of a galvanic cell theoretically with a pen and paper, not by, you don't have to perform experiment for that. So stay with me for the next lecture.